Well, at least it won't smell like a toilet in here anymore. Wait a minute. Those things are used in toilets. Frangipani fresh. Greetings, the Astro 30 here yet again, and welcome back to AEL. On the desk in front of me here is a portable signal generator, an FG-100, and it's probably made by JYE Tech. And I purchased this on Evil Bay for about 36 bucks. Now it's the tax return time of the year again, and I didn't get a very good tax return this year, but at least it's better than owing them money. So I went and bought this. So once I figure out how to get into the box, like so, it comes with the knob not attached. It comes with the unit, which is fairly thick looking, and a USB cable, as well as, well, a sheet here which just tells you information about the function generator. FG-100 DDS function generator, the main technical parameters, output waveforms are sine, square, triangle, forward sawtooth, reverse sawtooth. So that's about as much as you get. Power supply is 3.5 volt to 10 volt. It's recommended to use 5 volt when using the adapter, and 3.75 volt lithium battery when using battery power. Didn't know it could actually run on batteries. So it's not really that descriptive here, but it just tells you the features of it. It comes in a 125 by 80 by 32 millimeter size cabinet. Weight's approximately 175 grams. Complete functions, whatever that means. Simple operation, easy to carry. It can be powered by a power adapter or a 3.75 volt lithium battery. Together with an oscilloscope, it can be used for electronic circuit test and debugging, frequency characteristics, and impulse response test and measurement of audio amplifiers. Due to the good accuracy of the frequency stability of the DDS, it is also very suitable for oscilloscope sweep time factor calibration. The square wave output is suitable for oscilloscope attenuator and probe pulse characteristic adjustments. Well, with that pretty much useless manual, now this is the unit, and that potentiometer that is used for the output adjustment, that is crooked. Look at how crooked that is. So yeah, I'm most likely going to open this up anyway so we can take a look on the inside, but first what I want to do is I want to make sure, I'm not sure what that does. I'm just going to make sure that it even works. Now, it's fairly sparse on its functions here. You've got the run stop, a filter which I don't know what it does, DC offset adjustment, positive and minus. That knob is not put on right either. So that's, yeah, okay, and then when you rotate it the other way, that's there like that, and okay. So let me go get in a power adapter so I can plug it into this lead, and yeah, go from there. They didn't even supply the clip leads to connect to the output, that's annoying. I could have sworn that in the description of the product it came with it, but obviously it doesn't. Alright, this lead's not very long. It's only about a little less than a meter. Turn him on. It's not working. There we go. It wasn't plugged in to the PowerPoint correctly. It's got a basic display. It shows what type of frequency we're on, which is sine, and the frequency currently is set to 100 kilohertz. This is supposed to go up to 500, although it seems to go beyond that. Alright, so we'll zero that out and move the cursor over, and if I hit run, there we go, it should remember where we are and stop it from flashing. So currently we're outputting a frequency of 1 kilohertz, or it should be if, you know, this display here has anything to go on. It's kind of hard to discern. Let's go over to here. Can we change it from hertz to kilohertz? No, we can't. Alright, so let me hook this up to the oscilloscope and see what sort of output we've got. Right, and according to the oscilloscope screen, we do have an output, and this pot does actually achieve exact 0. It's only jumping around and a bit noisy like that because of the way the leads are connected. But it does go significantly high. Now, I need to change my voltage so that we can see the waveform a bit better. Right, well, we can see we've got asymmetrical clipping, and we're reaching roughly about 1.26 volt RMS. Not even that, almost a volt RMS, which I guess is okay. 2.7 volt peak to peak, and that's with it full up, and it's still asymmetrically clipping. What this DC offset does, makes the waveform jump a bit. That doesn't seem to affect the waveform too much. Doesn't seem to do anything. Well, it'd be doing something to the waveform, but exactly what, I don't know. Although the asymmetrical clipping has gone now. Aha, right, even with it off. Aha, there we go. That's why it was asymmetrically clipping. So that little pot here adjusts whether we've got a DC offset on the positive or the negative, and if we can put it roughly in the center, we can actually rotate this pot full and get a good 6.7 volt RMS output, which is quite significant. That's pretty cool. Alright, so what this filter does, currently nothing. I can't see anything on the scope changing. Right, okay, let's change the mode if we can. Stop it first, then change the mode. Square. And we have a nice square wave there. Stop it again. Change it to triangle. Nice triangle. You have to press run stop each time to change things. Sawtooth. Nice. And reverse sawtooth. Excellent. And 20% pulse. So that's a 20% duty cycle. I'm going to assume that that is a 20% duty cycle. I haven't got that measurement on the screen, but that's alright. ECG, which looks like a heart rate monitor, and back to sine. So those are the functions of the signal generator. So we know it works. How about now we actually take the thing apart? So what is the point of a portable signal generator like this? Well, a better screwdriver. There's nothing wrong with the little one I built last year, except it doesn't give a true sine wave. This one does. Plus it cannot achieve a zero output with the amplitude pot. So that's another reason why I bought this. And I bought this not knowing that, but I know now it does, so that's very handy. Also, when testing audio amplifiers such as BTLs, bridge tied load or balanced transformerless, you can't have the ground of your signal generator the same ground as the oscilloscope, because the output of the amplifier isn't grounded. And for instance, the oscilloscope has an internal generator which is grounded to the same BNC posts as the input. So you would actually essentially short the amplifier out and do some damage to it. So that's another reason for having a portable generator like this. Comes apart relatively easy. Oh yeah, the pot's just soldered in there crooked. There's one screw, two screws that hold it into the case. Of course the TFT, well not the TFT, the LCD is in the way. But that's okay. I want to just take this board out altogether because I want to see if I can just adjust that pot. So, oh, well, I don't need to hit it with the soldering iron, I just bent it. Okay, well, we'll put that to the side. This is a good look at the circuit board. I'm going to pull that knob off. Maybe not. There we go, because I want to adjust that so it's pointing in the right direction at minimum and maximum, etc. So let's get the LCD off. It's only going into a header connector here, so it doesn't have that, you know, special LCD felt pad conductive foam stuff that you've got to get in the right position for the LCD to work correctly. There's a adjustment pot here too, which I don't know what it does. So I'm going to leave that alone. I don't know what's more fun, buying stuff and testing it, or buying stuff and taking it apart. You be the judge. Okay, so move that out of the way and just carefully unplug that. And now we get a good look at the heart of the unit. It's using an Atmega or Atmega 88PA microprocessor here, and that would be what's responsible for all the functions of the generator, such as producing a sine wave output. There's a crystal oscillator there that's 30 megahertz by the looks of things. Yep, 30 megahertz. There's another adjustment pot over here, which I don't know what it does. Might have something to do with the LCD screen. So these two adjustment pots I'm going to leave alone because they're not actually marked as to what they do. And there's nothing worse than buggering up the calibration of the unit. However, there's nothing on the bottom side of the PCB. There's no like surface mounted chips on here or anything. Everything is basically all through hole, apart from the resistors and capacitors here on the top surface, which are mostly surface mount. Got a couple of through hole capacitors here. And that's it. It's not really all that exciting, and that chip doesn't look like it's in the socket properly, but alright. Well, I guess we've had a look and there's nothing really that interesting in here. We've got the potted display driver chips on the LCD screen board. Pretty much like, you know, what you find inside a calculator. Nothing really spectacular there. Before I put the case back on, I'll just check that the unit still works. Wherever my output leads disappeared to, there it is. hook that back up to the oscilloscope probe that came off of. Okay, plug it in. Where's the... There we go. Yep, it's actually made by EZM Studios, not JYU Tech. But yeah, it appears to be working. It's on 100. It doesn't remember, this is the only thing, it doesn't remember what frequency you were last on when you unplug it. So you've got to set this each bloody time, which is kind of annoying, but okay. So I've got a DC offset, but I can fix that, that's fine. Okay, so I want to put this knob on so it's facing the right direction. That's better. And about center is roughly where it needs to be, about there somewhere. So you get a nice even waveform and it doesn't clip asymmetrically. And actually more center than anything else. Alright, put the top on. So now I can pop this knob on, which doesn't even fit properly because that needs to be expanded a bit. I don't appear to have, yes I do. I'll just give this a slight separation. It still doesn't quite fit snugly. I don't want to damage the pot either. Yeah, that'll do. Okay. Hook that back up again. That is so annoying. Wrong. Alright. Yes, we have an output. Nice. Now, this does say that it can go from 1 Hertz to 500 kilohertz, as I previously mentioned. So let's test that on the oscilloscope and see what we get. I really need to tidy up in here. There's crap all over this desk. Right, I'm on 1 Hertz, and yeah, we can see that it is working, but of course 1 Hertz is a fairly slow frequency, so yeah, we're going to have not a very quick moving screen here. So that is 1 Hertz. I'm going to change it to, well, 10 Hertz and adjust my time base again. Which is, yeah, not bad. I wasn't really paying attention to what the voltage differences were, but I do have the amplitude up full. Well, now I do. So let me just go back to 1 Hertz, because it was around about 6.5 volt there. Just that time base again. I'm sorry if I'm boring you with this. Well, the frequency is too low to get a voltage measurement. I should say slow. Oh wait a minute, it is there. 5.5 volt at 1 Hertz. That's RMS. So we'll go back to 10 Hertz. And well, it's more like 6.7. Okay, next we'll go to 100. Okay, just time base again. 6.7 volts. So between 10 and 100 Hertz, it's the same voltage. So let's now go to a higher frequency, such as 10 kilohertz, We know 1 kilohertz is good enough, so we know that the voltage was roughly the same. Okay, we're at 10,000 hertz. Still 6.7 volt, roughly RMS. Okay, so we'll go to 20 kilohertz. Still the same voltage. Okay, so for audio it's a reasonably flat response. So now we'll go to 100 kilohertz. And I can see that the voltage is starting to roll off. It's getting a little bit lower. Alright, it also doesn't look like it's starting to clip strangely. Alright, let's go to 200. Voltage has dropped down to 5.6. 300. Yep, the voltage has dropped down to 4.6 and it's starting to asymmetrically clip. And yeah, the adjustment pot doesn't seem to do much. Go to 400 now. It's really starting to roll off in voltage. We're now at 3.45 volts. And its apparent maximum, which is 500 kilohertz, well, it's 2.36 volt RMS. I mean, this sort of frequency is not good for audio anyway. Alright, let's see how far this thing can go before it just stops functioning. 600 kilohertz. We've got 1.54 volt. 700. Now we're down into millivolts, 948 millivolts. But the scope is still actually reading what the frequency is, which is good, so I need to increase my time base. But alright, the maximum this can go up to anyway is 900, so we'll go to 800. We still have a signal, but it's only like 621 millivolts, and it no longer really looks like a sine wave. So finally, 900. That looks more sawtooth than it does sine wave. And we're at 389 millivolt. So if I now go 999 9 hertz, that's almost a megahertz, and it still does it. Nice. Alright, well, we've done as much testing as we can with this thing. So in conclusion, for what I paid for this, which was only about 36 bucks, it is a reasonably good little oscillator. I mean, there'd be no reason why, with testing audio gear anyway, I'd want to go to near a megahertz. But it can do it. It's just not very, doesn't have a very powerful output at that mode, that frequency. So all in all, I would recommend this as a basic DDS. I mean, it doesn't have a sweep function on it, and it doesn't have like modulation function on it, so you can use it for radio circuits, etc. But it does have basic functions on it, which is perfect for audio enthusiasts. I really should hook this up to an amplifier and see how the sound sounds, like what it sounds like on the output. Yeah, I might do that before I close the video. Alright, it's hooked up to an amplifier. Sounds alright. It sounds better than the other oscillator does, because that sounds a bit harsh on the audio output. Yeah, this one doesn't sound that much better either, but I guess it's okay for what it is. 200 Hertz. Yeah, it doesn't sound the best. Oh well, you can't have everything, I suppose. Yeah, it's got that nasty ring behind it. But it's okay for testing amplifiers, I guess, into an oscilloscope. Anyway, I hope you enjoyed this video. If you did, please remember to go down below, like, comment and subscribe if you haven't done so already. And this is Yasha3 saying see ya, have a great day. I'll see you in the next video. Thanks for watching.